Hello everyone, friends. My name is Vladimir Alifman. Welcome to my channel, and we are going to have an intense lesson today. We are finally starting to write our first smart contract. We will fully configure our environment for work. We will get acquainted with what programming languages exist in the TON, and actually write our first smart contract and even learn how to test it. Therefore, sit down comfortably and we will begin. To begin with, a little theory. What kind of programming language is in TON? And the answer is we have 3 of them. But don't worry, we will only be teaching one. And if we refresh the history a little, then in the distant 2019, there was only one programming language. This is Fifth. And it was a very hot topic because a fifth is almost a bytecode, close to machine code. Literally, only a limited number of people could write on it, and they could not create large projects as decentralized exchanges, marketplaces, and so on. Now, Fifth is used for some very specific tasks that you and I definitely do not need in this course. The second one is FunC. This is no longer as assembler-like language, it is a C-like language, close to high-level one. And if we have FunC, why don't we write FunC contracts? Why do we need another language? And the point is that FunC does not have the classical understanding of programming that the vast majority of developers are used to. This is a language in which you will have to work with cells, different registers, and build cell trees. And of course you can develop big projects with this approach. FunC is well suited for developing protocol contracts, such as wallet contract, multi-signature wallets, and so on. But not for large projects with a large number of smart contracts. But we are creators, builders. We want to come out with new blockchain application and create these projects. That's what the third language is for. It is Tact. It's still a very new programming language. I have been watching its development almost from the very beginning, and I really like how it develops. And as you could already see on my screen, the process of creating contracts will be as follows. First, we write contracts on the Tact, then we build our projects in FunC. Here I can give such an analogy of TypeScript and JavaScript. Eventually, JavaScript is launched under the hood, and TypeScript is compiled into it. The same way, Tact is built in FunC, and FunC goes to the compiler for Fifth, which is compiled into bytecode and deployed into a blockchain. Such a complex sequence works under the hood, while you and I will use only Tact. Okay, we are getting to work. I've been working in Visual Studio Code. This is a free IDE that will suit us for our tasks, and I immediately recommend that you install the following plugins to work. TAC language support, and I also recommend downloading FunC. Despite the fact that we will not work with it, we will sometimes open files with code in FunC. Okay, we will work within the Blueprint framework, and this is a framework that has appeared recently, as in fact everything in the TON blockchain. But before recording the course, I consult with representatives of TON Foundation, and that's why I know that this framework is a long-term project that will be developed for developers. And that's why we will work with it on our course. So that if you watch this course a few years after its release, it will continue to be relevant. So let's get started. In order for us to run our framework, we need to enter the following command. And here I must say that, of course, for us to work, we need to have Node.js. I will not install it now because I have it already installed. So if you haven't installed it yet, install it yourself and we will proceed. Here I confirm that I need to install additional packages, and Blueprint suggests that we keep the name of our project. Let's call him first lesson. Next, we need to keep the name of our contract. Let's call it the first contract. And now we have options for creating the structure of our project. The first two options offer us to create a project on Fancy. We will not do this, we will go to the tagged. And here it is possible to create an empty project or create a project with a simple contract with a counter. In fact, as part of this lesson, we'll write exactly this simple smart contract with counter, but we'll do this from an empty contract. I choose to create an empty contract. So our project has been created, and let's go in order. The first one is build folder. That is where our contract goes, which is converted into a fancy code. We will come back to this later, but for now we'll continue and look at the next folder. This is contracts. Here we have created our empty contract. There are also import. This is a standard library, it is written in the fancy language. We don't interact with it in any way, it just needed under the hood. Next we have scripts. In this case we have only one script here. This is a script for deploy of our contract. Next is the folder with tests, also with a ready-made template for the test. And the last folder, wrappers. This is a representation of our contracts that we wrote in tagged in the format of the TypeScript class. But about everything in order. First, we'll just work with tagged and write the first functionality in our smart contract. To begin with, let's analyze what we already have here. In order to create a new contract, we use the keyword contract. Then we write the name of our contract. Here we see a way of inheritance in tagged. To do this, the keyword with is used and then goes the entity from which we inherit. We will discuss this in detail in other lesson. And then we see the method init. In fact, this is an analog of constructor only within the framework of our contract. This is a method that will be called once during the deployment of this contract. As I have already said, our task for today is to create a counter contract. And for this, we'll need a variable counter. The syntax in tagged is such that first we write the name of our variable, then we specify the type of this variable. We'll have it as an integer, and then we also need to specify the amount of bit. We'll have it 32. uint32 means first of all that our number will be positive, 0 and more, and also that its maximum value will not exceed 2 to 32nd power. This is equal to this number. Next, in our method init, we must initialize the value 0. We do this through the keyword self, thus we say that we are addressing to the storage of our contract, and then through the point we get counter. And as you see, contracts in tagged are very similar to classes in classical object-oriented programming, in which we have a storage, that is, we store some values in our variables. We have getters functions that allow us to read the storage of our contract. As you can see, I indicated the getters functions through the keyword get, followed by the keyword fun and name of our function. Then, similarly, with variables, we have a type that this function returns. And the third component of smart contracts is the ability to receive and send messages. To do this, the keyword receive is used. Next, the content of the message that we want to receive. In this case, let's make the functionality for receiving a text message increment. And in case we received such a message, it means that we need to increase our counter by 1. Great, we wrote our first smart contract. Now, in order for us to use it, we need to make a build. Let's go to README and see what kind of command is needed for this. We are writing this command npx blueprint build. Also, friends, I want to warn you that if you work on Windows, then you may have a compilation error when building the project. This is a well-known error, it is marked on the GitHub repository. I don't know when you're watching this video, but if this bug is not already fixed, I can recommend you one service. This is Gitpod. In it you can set up your virtual IDE, development environment, connect it with your GitHub and take a course within this service. Users on Ubuntu and macOS will not have such problem. But in any case, the description will contain a link to the GitHub repository of this lesson, which will also contain a build, so that you can use it in case you have problems creating your own build. Okay, let's continue. npx blueprint build. Super! As we can see, our build was successful, and now it's time for us to go to our test. The test in fact creates a virtual blockchain for us, in which we can execute contracts, launch transactions and transfer cryptocurrencies. In general, to do all the same things that we do in a real blockchain, only with the help of code to track all the events, transactions and state of contracts, and much more. But as usual, let's start in order. The test starts with the describe command, which indicates which contract we are testing. Next, we initialize the blockchain variable. Through it, in the future, we'll get access to our virtual blockchain. And then we initialize our first contract. That is, here we have created, declared a variable, and here we already initialize it. Initialize our blockchain. Next, we initialize our contract. And here I want to show you exactly how it is taken. That is, our contract is taken from the first wrapper contract file. If we switch to our first contract, we won't see anything here, because the tagged compiler has already done everything for us. Go into the file in the builds, we'll see here a large TypeScript code in which we can even find our methods, such as getCounter. Here's an important remark that of course we wrote just a getter counter in the contract, but it is important to understand that the tagged compiler renames it and adds the word get, like getCounter. That is, for each getter name we must understand that in our TypeScript representation of the contract it will be called like this. Okay, go back to the tests. Next, we see here that a deployer object is created using the template. That is, in fact, we take from the blockchain using the treasury method, and then we write any line as if it were our seed phrase, private key, and get a wallet object. And the treasury returns us wallet containing 1 million Toncoin. As you can guess, from this wallet that we will be deploying, how to do it? In our first contract object, there is a default method, send method, which takes the following values. This is the sender, the one who will pay the commission for gas during the deploying of this contract. Despite the fact that the blockchain is virtual, you still need to pay a commission in it. Next, we have arguments. In the argument, we pass number of Toncoins that we will transfer. The bounce argument, we'll talk about it in the other lesson, and then message. And here even the Visual Studio tells us what options we have. Remember, we announced by the receiver method that our contract can receive text message increment, and here the Visual Studio tells us about this or about deploy message. Where did it come from? It came from the inheritance of our first contract from the deployable trait. And now we'll see what kind of deployable it was. To do this, we'll switch to the GitHub. I'll copy it under the deployable and we can see the following here. We see several messages here. Let's delete this for now, we don't need it here at all. And we see the trait deployable. We see that he has the only one receive method that receives the message of the deploy. If we compare it with ours, our smart contract is still able to receive only a text message. Deployable is able to receive only the message that is announced here. To do this, the word message is used, followed by the name of the message that will be transmitted and the body of the message. In this case, there'll only be a query ID with the integer type. and everything that this deploy do, he receives this message and notifies sending back a message with a deploy OK. This is a standard functionality that is needed for every smart contract, but now we can remove it. Let's go back to our code, and in the test, in order for us to deploy our contract, we just transmit this message. That is, here we have an object declared, inside we have a message type is deploy, and then there is the query ID. In principle, that's it. Our template test is over. All we have left is a check that our transaction will be deployed and will be successful from the wallet we expected. So by default, we'll see that our test is written only to verify that our contract has deployed as we expected. Let's run this test. To do this, we write a command npx blueprint test. Yes, the test passed. Let's add another test to it, namely to check our increment. Let's name our test should increase. And here we'll change the basic code a little bit. We'll transfer our deployer to the scope above, so that we can access it in other tests. So here we'll declare our first variable is counter before, and we can get it via first contract getCounter. It's a asynchronous function, so we'll write operator await here. It's important to say that our first contract was initialized with the help of the object blockchain. In other words, our contract was opened within this blockchain, so you can pull data from it and send transactions and messages using this blockchain as provider. Okay, let's go back to our counter and let's log it into the console and send our message to contract. We'll do this as from the example above. To begin with, pass the sender from the object deployer. Then we have arguments, the number of toncoins that we want to transfer. We'll transfer 002 toncoin, and then even Visual Studio tells us what we have increment message. Fine. And now we are going to take out our counter again. There is a TypeScript error here. Let's fix it. And now let's get our counter again. And our test is going to be very simple. It will be expecting that our counter before will be less than the counter after. Let's try. Yes, we can see that the tests have been passed. Let's look some more in the console, and we see the value of the counter. At first it was 0, next it became 1. Okay, let's improve our contract a little bit. Right now our contract can only receive text messages. Let's make it able to receive message objects, like in the deployable example. To do this, we create our message with the keyword message. Let's call this message add, and it will contain a single field, is amount, which will be of the type integer, uint32. And now we write a new receive method which will take messages, and the type of this message will be add. So that our contract is now able to increase the counter not only by 1, but also by the value that was sent in the message. Let's try to test it. First, we need to build our contract and copy our test should increase, and I'll change it to should increase with amount. We'll have an amount 5, and now the body of our message should be not just text, it should be an object. Let's see that Visual Studio tells us that we have two options, add and deploy. We choose our add. Next is amount. Amount here should be a big integer. Great. And run our tests. Super, our test was successful. We can see here counter before and counter after. Well, friends, I propose to go beyond test. I propose to send this to real blockchain. To do that, we need to make one important addition in our contract. The point is, when contracts deploy into the blockchain, they all have a unique address where it can be found on the blockchain, and that address is calculated based on two factors. One is the code of the contract, and the second is the initial state, or in other words, the original storage of our contract. Now the original storage of our contract is counter 0, but if that code and data already exist in the blockchain, we won't deploy it. We'll just going to knock on the already existing contract, but it won't be our contract. In order to deploy our contract, we have to add to it something unique. We are going to add an ID to do that. An ID variable will also be an integer, and now in our init method we'll pass it. And also I'll write getter for ID. Press build, and that's it. Now we are really ready to deploy our contract into blockchain. After building, we will see an error in our contract. It is because now when we are declaring our contract, we have to specify an argument. Well, let's put some random number. It's got to be a big integer. Okay, let's start deploying. So we are going to pass in from init some ID. I'll put a random number and call the command npx blueprint run. Here blueprint is asking which network we want to use. I want to use the testnet, and then we have options through what exactly we will deploy our contract. I will use the first option, is a wallet tokenkeeper, wallet which we installed in the previous lesson. And I have generated a link and QR code which I have to scan in order to my wallet connects to my project. Great, connection established, and then a transaction is generated to create contract. So the transaction is sent and we are waiting for the contract to be deployed. Great, the contract is done. We have got link and we can see it in the token scan. Yes, we can see that everything went well. Let's now write a couple of new scripts, namely getEncounter, which will allow us to read our contract. I'm going to copy the code from here and change just the main part of it, which is the counter, and let's also look at our ID. Now that we have a new script, we can call it via same command, npx blueprint run. And here the framework offers us to choose which script we want to run. getEncounter, we choose testnet, and see that yes, the counter is 0, and the ID is also correct. And now, friends, I want to directly from our wallet send a message to our smart contract that we created and use exactly the text message that the smart contract here is ready to receive. Let's try to do this. I insert the address of smart contract and send, for example, an amount of 0.2 Toncoin, and we send message increment. That's it. The transaction is sent, and let's run our getter again. Let's choose the testnet. And yes, counter was indeed incremented. The last script I want to write here is the addEncounter script. We'll also copy the basic code, put it here, and now we'll write the sending of our transaction. Okay, we save it and then we call again. Blueprint run, select the add-in counter method, testnet, tonekeeper, and as we can see, our result is expected. And that's it. Friends, thank you for your attention. See you on new videos, and goodbye.